Hey class, this week we're looking at Venn diagrams. So we're continuing probability. Mikey made the lesson for us, so I'm just going to go over how to work these problems on Google Slides. It requires some dragging and dropping and some filling, so Google Slides makes more sense this week. So let's just jump into it. So first kind of problem, we're given the universal set, which is the natural numbers 1 through 12, and tells us to determine the elements in the following subsets, P and P complement. Draw a Venn diagram of set P. Determine the probability of getting an element from set P complement. So if we look, P is the prime numbers. So if you remember, it's all the numbers that have 1 and itself as its only factors. So 1 does actually not count as a prime number. So you could put this in set notation, or you could just list it out, it's fine. I'll just list it out. So 1 does not count, but 2 does, because the factors of 2 are 1 and 2. 3, 1 and 3. 4 also has a 2 in it, so that doesn't count. 5 works. 6 does not. 7. 8 does not. 9 does not. 10, 11 does, but not 12. So this is what we have for set P. 2, 3, 5, 7, and 11. So if you remember, that superscript C, that stands for complement. That basically means the opposite of this set. So if everything in the world, our universal set, is 1 through 12, and we have 2, 3, 5, 7, the opposite of that, the complement, would be those numbers we haven't listed yet. So let's list them. 1, we've got 2, we got 3, we don't have 4, we don't have 6, we don't have 8 or 9 or 10, and we don't have 12. So now we should have all the numbers, because if we have the set and its complement, that's everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's everything. Now this notation stands for probability of the set P complement. So this is asking us, what is the probability of getting something from P complement? Well, there's 1, 2, 3, 4, 5, 6, 7 things we want, 12 things we in total. So 7 out of 12. Remember, probability is what you want over the total. 7 over 12. There isn't a equation builder on this one, so you'll have to kind of just make do like that. Just hit the 7 and an enter, and it's going to try and mess you up with those dots, depending on how your text box is. It doesn't need to be perfect. You could even, if you prefer, you could do it horizontally. Either one of those is perfectly fine with me. So you do it horizontally, you don't need to do any extra work. There it is, 7 out of 12. Boom, done. Now it says shade P complement, so we actually need to draw the Venn diagram set P. I'm going to use an ellipse to represent my sets. Well, that's just kind of standard. And I'm going to unshade it for now. I'm going to make it white. Don't make it transparent, because whenever you need to shade things, I have this back here, which you can actually move, but don't. That's for shading purposes. It's better if you make your background white until you're ready to shade. So this is going to be set P. So I'm going to name it P. That's not a P. P. There's a P. And inside of P, we have these copy and paste them. Thank you for being on a computer. It makes it a lot easier. And P complements everything else. So you actually don't have to put it in there, but if we did, it would be anywhere outside of that ellipse. So I want to shade everything that's not inside this ellipse. So I'm going to click on the background here. Here's my bucket. And you can fill it with yellow, or if you like red better. Don't fill it with white, because, well, then I can't tell what you shaded. Black, you could do that if you really wanted to, but yellow or red would be good, or blue. A light color that's easy to see where the boundaries are. So that's how you go about doing those. Not too terrible. Now it's just asking for the probability. Well, what's the total probability? 100%. One solid number, 1. So if I have the probability of A being 78%, or 0.78, then A complement has to be everything else, which is 1 minus 0.78, which would be 0.22. That's not a calculator. There it is. So all you need to do to get the probability of A complement is do 1 minus the probability of A, 0.78. 50ths. This is in a decimal, so I'm going to write it in a decimal, 0.22. You could write it in a fraction, but if they give you a decimal, you might as well keep with what they give you. If they gave it to you as a fraction, then I'd suggest writing it as a fraction. Makes it easier on you and me. So that's how you go about doing those. Just do 1 minus whatever A is to get the complement of A. All right, this says we've got these different relationships here. So if they're mutually exclusive, they're not touching each other, there's no overlap. There could be something with some overlap. Set B could be entirely a subset of set A, or set A could be a subset of set B. So that means everything in set B is inside of A. This means everything inside of set A is inside of B. So our universal set is the numbers 1 through 20. And we need to look at these guys. Set A is even, set B is odd. Is there any overlap? No, they're mutually exclusive. One's even, one's odd. So this is relationship number 1. So I'm going to stick a 1 in the blank right here. Boom. That's what it's going to look like. If I drew this Venn diagram, it would look something like this. Okay, we got the even numbers, and I got the numbers 2, 8, and 10. Well, all of set B is even, right? So all of set B is inside of set A. So if I look, that's relationship number 3. Set B is inside of set A. And let's see. Set A is the digits and the date 1964. Set B is the numbers divisible by 3. 1's not divisible by 3. 9 is, 6 is, 4 is not. So it's got some overlap, but not everything. So that's relationship number 2. There's some things they share, but they also have things that neither one of them have. Okay. So text box. Number 2 for that relationship. So that's how you'd answer those. Pretty simple. All right, so this has 6 sets of instructions on what to do. Determine the elements of the subsets, determine where they intersect, draw a Venn diagram, determine some probabilities, determine if they're mutually exclusive or not, and shade the required region. So this down here pretty much walks you through that. Set A is the multiples of 6. And again, we're still looking at the universal set of the numbers 1 through 20. So just count by 6s, skip count. 6, 12, 18, 24 is too big because that's outside of our universal set, right? We can only go from 1 to 20. Anything outside of that doesn't exist for this set. So 6, 12, and 18. Now, on this one, we have the numbers greater than 16. So that's strictly greater than, so it doesn't include 16. So 17, 18, that's a weird one, 18, 19, and 20. Again, 20 is the biggest number we have. We have only numbers from 1 to 20. So we can't go above 20. So I'm going to go ahead and draw these Venn diagrams. If I look at it, they do share 18, right? So they got 2 sets. I'll change the shading in a second. Actually, I'm going to copy that. Again, make it white. And on the second one, I'm actually going to make it transparent for now. Because if I make it white, I can't see behind that. So if I make it transparent, I can now see. All right. Are they mutually exclusive? No, they're not. So I'm just going to circle that. And make that transparent so you can see. You could also box it or type it or... One second. Okay, I'm back. So now it asks the probability of multiple of 6. That's 3 out of 20 numbers. So 3 out of 20. For convenience, just use horizontal. 20. Greater than 16, that's 4 out of 20. And you might be thinking, can I simplify that? Of course you can. 1/5. What is set A intersect set B? So let's go ahead and fill these out. Okay, so I'm going to name them. I'll call this one set A. This one set B. Okay, so if I copy these, set A, is over here. Set B is over here, but what do they have in common? They have that 18, right? So they share 18. So that is their intersection. So 8, oops, sorry, I have no idea what I just did. Undo. So 18 is what's going to go in here. That's the intersection. So that's what our set should look like. And this intersection is 18. So if we have an and, that's an intersection. How many numbers do they both have? 1 out of 20. So probability of multiple of 6 and greater than 16. So there's only one chance of that happening. That's if we have an 18 and there's still 20 numbers out there. What about set A or set B? Well, if we look at it, there's 3 numbers here and 4 numbers here, so that's 7. But we have to take away what they have in common so we don't count it twice. So that's 6 out of 20. And if you wanted to, you could count 1, 2, 3, 4, 5, 6. So 6 out of 20, of course, that can be simplified to 3 out of 10. Probability of multiple 6 or greater than 16. Oh, sorry. I actually did the probability there. This is asking for what is that set. Well, that would be this set combined with this set. But again, we're not going to count that twice. So there we go. That's what they are. We have 1, 2, 3, 4, 5, 6 elements in there. Now it says shade set A intersects set B. Okay, so here's where it takes a little work. And notice how I had this one transparent so we could see behind it. This is why. So you're going to come over here and you're going to select the curve tool. Okay. And you're just going to click on this intersection part. So I'm going to click, go a little bit, click, go a little bit, and click, go a little bit, click. And just keep doing that all the way around. And if you do it in line right there, it'll connect. So start over. Click, 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 click. A little further this time. And it's not going to be perfect. I'm going to shade that part yellow. So that's what needs to be shaded. Now, my 18 is hiding back there. So I'm going to cut it and paste it back. And now it's in front. You could also just type 18 over it again. So this is what needs to be shaded, the intersection of the two. So this curve tool is what's going to help you do that. So if you need it, let's just do a few different possibilities. Let's say we needed section B, but not A. This is not for this particular problem, but we do the same kind of thing. We'd make this intersection part, but we'd shade it white. And we'd shade B yellow. And that would be B, but not A. So, you know, you can play around with it however you need to do it. Just make that little intersection part with the curve tool. And then you can click over here for the universal set if you need the universal set. Notice B is transparent right now. That's why it's not white. That's why you need a white background on these. All right, here's some practicing with shading. Set B and A complement. So that's exactly what I just did. For these shading ones though, if you didn't have to draw the Venn diagram yourself, I already made that curve section for you. So what do I need? I need this part shaded right here. Shaded. E and A complement. It's an and. So that's what it is. If it was an or, you know, then we'd have everything that wasn't A shaded. All right, so that's how you do the shading ones. Again, they have different sections already for you, so you can shade the different pieces different colors. So you see the different sections here. You have the universal set, you have B, you have A, and you have the intersection of A and B. So just click on whichever one you need and highlight it. Fill it in with this paint bucket. All right. Place the values in the Venn diagram and determine the missing probability. A and B is 0.12, so that goes in here. 0.12. Probability of A is 0.53, so that includes that 0.12 right there. So this whole thing, 0.53. I'm actually gonna move it over here so it's touching that line so I can know, yeah, it's inside of both of them. That's a little tiny, I'm gonna make it bigger. How about 25? That'll work. So now I can see this 0.53 is all of set A, including this section here. I want the probability of A and not B. Well, that's just this section here that doesn't include this 0.12, right? So I do 0.53 minus 0.12. And I get 0.41. Easy as that. No shading required. I believe that's all the different kinds you'd have. So again, the only kind of tricky thing is having to use that curve tool whenever you're doing these intersections, if you have to draw the Venn diagram yourself. Other than that, it's pretty straightforward. So that's the first lesson of Venn diagrams done. Moving on to the next.